Hello everyone, my name is Bar and I'm here with Nuphar. We've created together a project in Advanced Software Development course that we're going to show you now. In the final stage of the project, we've created a manual joystick that controls a flightgear simulator of a Cessna plane. We've completed during the course 5 milestones that we'll explain shortly, demonstrate in a video the joystick controlling the Cessna plane, and in the end talk about the design pattern that we used in the project. So let's begin. In the first milestone, we did a design of a server-side architecture using solid and graph principle, which we learned in class, that basically explain how to write a correct and smart code. The server is using a client handler in order to solve problem, meaning the client handler has a handle method that receives a general problem and return a solution to the server. In the second milestone, we implemented the architecture from the first milestone using a cache manager and file streaming that are handled by a client handler. Meaning the handler is getting through the file streaming a certain file in a buffer reader and print writer, and using the cache manager solve problem. The client handler solve a certain problem and save the solution in the cache manager for future references. If a new problem arrives, the cache manager check if it was already solved before. If it does, it sends it back to the server. If not, the client handler save the new solution in the cache manager. In our case, the client handler received strings and was supposed to reverse them. He checked with the cache manager if the reverse string was already existed. If it does, he sent it without solving it again to the server. If not, he reversed the string and then saved the solution in the cache manager. In the third milestone, we dealt with the general search problem and the implementation of several search algorithms. In our specific case, we tried to find the shortest path in a maze matrix. We did a research which search algorithm is the best, for example, A star, BFS, and DFS, and more, and realized that BFS was the best one for the specific problem. In the fourth milestone, we created a new language that interprets commands from a string file, meaning we get a string file which has a lot of string. All of them are real commands from the flightgear simulator, and using Alexa and parser decompose each line and each word to create a suitable command object. All of them were inherited from a command interface which has the basic method of do command. In the fifth and final milestone, which is based on previous milestone as well, we've created a GUI, meaning the manual joystick that controls the flightgear simulator. So let's see a demonstration. We have the flightgear open. Let's open the client. It will open the joystick. We're in manual joystick. Let's connect to the flightgear simulator. You see we're connected. Let's auto start the Cessna plane. You can hear the engine. Now we'll pull throttle to the maximum. You can also see it here. Now we're moving. Let's balance ourselves with the rudder. You can see we're balanced. Now let's elevate. You see that we're flying. Because it takes a lot of time to go to a specific altitude, we'll just show you the aileron just for the call. You see we're moving to the side. It's working. Great. Now we're disconnecting and you see bye. So let's talk about the design pattern that we used in the project. We've used MVVM and Observer pattern. MVVM stands for model, view, and view model. The model has the view model, and the model. The view, in our case in javafx, is a fxml file, is the design of the joystick that you've just seen. The view send command to the view model, and the view model send it forward to the model. In the model, you have the algorithm, and if something changed in the model, he sends notification to the view model and back to the view. The view and the model doesn't know each other and communicate through the view model. The notification that are being sent from the model all the way to the view are being made by the observer pattern. The model is an observable and notify all the observer, which the view model is one, and the view model is also an observable which notify to the view, which is an observer. Also, between the view and the view module is data binding, meaning every time something changes in the view, it will change also in the view model and vice versa. So, thank you for watching our project. We hope you enjoy as much as we like making it. Again, my name is Bar, and here with me is Nuphar. Have a great day. Bye.